Hello, and welcome to a demonstration of converting binary to decimal and converting decimal to binary. These weird formats here are what you would usually see in networking as an IP address. So don't get overwhelmed by all the different little things that I have up here. We're going to go over things piece by piece. This is just so I have all my junk on the table, so to speak, so that I can organize it like that. There's a method to this chaos. So first and foremost, let's take a look here. So this is from a textbook it's trying to explain how the heck to do, this is talking about hexadecimal for one thing, which we're not doing hexadecimal here. This is just normal decimal, so out of base 10. But first of all, so this also explains what binary is, but this is a terrible, terrible explanation. It doesn't make any damn sense. So suppose you have something like this, 0x6a, and this is the first time in the textbook that the 0x thing is introduced. They didn't, like, you should have this before. Hexadecimal, like when they first talk about hexadecimal, hexadecimal is sometimes represented with 0x at the beginning of it, just as an indicator that you're talking about hexadecimal. So this is just bad that they just kludged it on the end there. That's very bad structuring. So what are binary and decimal values? To correctly answer that question, all you have to remember is that a hex character is one nibble, and two characters together make a byte. So this is supposed to be like a measure of data, like, a byte, and this is a portion of a byte. And this is completely meaningless. This doesn't make any fucking sense at all. Each hex character is one nibble, and two hex characters together make a byte. What the fuck is the significance of that? It just stops there. It doesn't explain that further. Give me some meat here. Stop serving me salad. I'm going to die of malnutrition. There's not going to be any formation of memories in my head, you piece of crap. God, you don't just present information. You present information and connect it to something meaningful, and then that makes it fucking memorable. This is bullshit. To figure out a binary value, it just continues on. It ignores that it did not attach any connection there. I presented the information, so now it's up to you to learn it. That's just shitty structure. To figure out the binary value, first put the hex characters into two nibbles and then put them together in a byte. What the fuck are you talking about? So, okay, two nibbles would be, so each one is a thing. So you just have four fucking characters together. Is that what you're trying to say? So 6 is this in binary, yeah. And so the complete byte is how many binary things? Oh no, it's not a regular amount of spaces because it's expressed in binary. But then how the fuck do you have the delimiters? So where do I know that this is 6 versus something else? Because if I just read this whole fucking thing here, then I would have 1, 2, and then 8, 16. Like this whole thing would be like 1,000. It'd be something else. Like we can do this conversion over here. So we have how many spaces? This is not using any delimiters. So we have an example here. So it'd be 1, 2. So that'd be 2 plus 8. It's actually, I'm going to write a note here. There we are. I'm draw on this. So since we have that there, so we have 2 plus 8, which is 10. So I always write in, come on, just give me a pen and let me write. So I got 10. That is really thick to be writing with. Can I get a thinner size? Thank you. It's 10, and then 5 over 1, 2, 3, 4, 5 is 32. Because we're skipping 16, so 32 and then 64. 32, 64. And writing with the mouse is quite a mess, as you can see. So that's 106 in decimal. Is that what you were trying to express? And see that this doesn't make any fucking sense. So trying to relate this. See, what I'm trying to do is I'm trying to connect the bullshit that they're presenting here. Well, yeah, this is hex and this isn't supposed to be hex, it's over here. But if we are trying, I am grasping at straws for how the fuck do I connect this information together? And the bullshit example that you give here is unrelated to the bullshit that you get tested on later in the end, which is what we have. This is like the end of the chapter test thing that goes on over here. So that this is just shit structuring. I'm very sorry if this seems frustrating. This is just extremely poor writing. I do not see how you would be able to teach from a textbook like this. I would just edit this shit out unless you are going to have meaningful examples of hexadecimal conversion in some kind of applicable context. I know we're not using hex for the IP addresses over here, but that's shit. Put that in another fucking chapter where you like, so you can introduce decimal to binary conversion for the purposes of IP addressing. Hex isn't fucking involved, so why the fuck is it in this chapter? Move it to another chapter where you learn about something where you need to do hex, because you can just introduce fucking binary, and then you can go, oh, now we can convert this to decimal, or we can convert this to binary, and this is useful because, instead of this theoretical bullshit that okay, put it into nibbles, and then you have this broken up into other nibbles, each nibble being 5 because bits 1 and 4 are on, which makes the hex answer this. What the fuck are you talking about? In decimal, the binary number is this, which converts to 64, 16. Okay, so how you... And they don't fucking explain this. That you're looking at... So when you have you can set up a conversion table really simple. It's just... times 2, times 2, times 2, times 2, times 2. That's how we're getting binary here. So that's how we're getting the places. What's in what place. So, and there's no demonstration of filling out one of these tables, which is why I wanted to record this. It's because this is absolute bullshit where this shows up on the test portion of this chapter talking about, binary conversion to decimal and back and forth. But they never show the process for this. It's like, okay, I get that these numbers relate to these things in the this is binary, but how the fuck do I get there? And this is just fucking gibberish. With, I know, like, technically it makes sense if this as so, like, seeing this stuff and not being technical with understanding what the fuck you are trying to relate this to. This is just poorly structured bullshit. Get lost. It's not worth my time. I just have that to show you how shitty the instruction is. So let's actually go to expressing something meaningful here. Unfortunately, I'm struggling to see this underneath that. So 172. So let's just do 172 here. So 172 minus 128. What would that be? That would be 4 to give us 3. That would be 44. So we have there, and then we have... So what I'm doing is I'm subtracting, the number that we have is 172, and I'm subtracting 128 from it. So you take the largest, given whatever number you're starting with, you take the largest number here, and you subtract from it. So I have my tick mark for, okay, 172 is going to have at least one item in the 128 range. And what do I have left over? It's supposed to be 28, and it should be 44. Because 44. So then what's the next largest one? Well, nope, 64 is too big. 44. I can do that. And I apologize with this being small. Maybe I should have this a easier to see color, going a bit larger with the size here. 44 minus 32 gives us 10. And then to get 10 out of this, we just have 8 and 1. Because 10 minus 8 gives us 2, and then we have that. So our whole binary thing would be 101, 01, 01, 0. But that doesn't fucking mean anything unless you see that process. So that's how we got the 172. So the next one that we have is 16. So for 16, all I would do, and this sucks that I have like such a limited space to show this with. let's get that bigger. Not what I wanted to do, but regardless. It sucks that this is overlapping. So we're just going to do 16 and then we're going to do 20. So 16 is just there. So 0, 0, 0. Oh, it's 16. And then the rest of it is zeros all the way through. It's zeros all the way through. So if it's just one of these numbers, like how it's 16, I apologize for that. So if it's just 16, then you just have a 1 there and the rest are zeros. So this is shit because the edit shit is in the way. So fuck the rest of this. It doesn't fucking matter. We're just doing a couple more examples and moving on. So 10, as I showed before, was simple. It's 8 and 2 gives us 10. But if everything is expected, and I don't know the correct terms for this because this was not fucking discussed in this chapter, but sometimes there's a number of bits that are expected. So a 1 or a 0 is a bit. So I could have a string of, here it'd be 1, 2, 3, 4, 5, 6, 7, 8. It could be 8 bits that are expected for each number unit. So you would have to have zeros heading it if it's a certain format that requires that number of bits. I don't know the relevancy of that. I don't know if you could be shortened to only having 4 items and it would still be interpreted as being 10 for 1010. I don't know that. And I don't know what the situation would be if you had something that was even greater, that went to 600, where you'd have to have another bit or another 2 bits even for that. None of that is discussed. That's beyond the range of this discussion or whatever the hell. But it's failing to express the significance of what the fuck is going on here. Of how do you tell one location from another? Here, it's real simple because we're just converting over whatever the hell is in decimal here. And then we are supposed to fill out all of these spaces with either a 0 or a 1. At least that's implicitly what we're supposed to do, because when I was at the practice exam portion of the text, this is the first time that these tables were introduced. They should have gone through part of the chapter and express how to fill out these tables like I'm doing here. Like with going, 10 minus 8 gives you 2. The next largest number is 2 there. Okay, and then you just zero it out. And so that would give you 1, 0, 1, 0 to give you 10. Interesting. So if I had 11, then we tick up. And so it's 1, 0, 1, 1. 12 gets interesting because these are already active. So it'd give us 1, 1, and then it zeroes out. Because 8 minus 12 gives us a remainder of 4. Then, and we have that 4, so we zero out the rest of it. So how do we do 99? I'm just going to give us some space here so that I can do things, because 99 is going to be interesting. Okay, so what's 99 minus 64? And I am doing this longhand to make it clear. That's a 9. So we got 35 remaining. So we have one item here. Let's just use this margin space, this margin bottom, to put our 1s or 0s so that we have this space to do the calculations nice and large. And then 32 is the next largest one. And 35 minus 32 gives us a remainder of 3. So nope, 16 is too big, 8 is too big, 4 is too big for 3. 2, we can take 2 out of that, which gives us 1. And then we flip on the switch for 1. So our binary for 99 would be 0, 1, 1, 0, 0, 0, 1, 1. And it's not clear if it's acceptable to drop leading zeros or not. That's just not discussed at all, but I'm assuming since this number of places are given, that this is the number of bits that they want returned. The return value does not have, what is it called, arity? No, arity is the number of parameters that you're supposed to have. It's just like enforcing a number of It's not decimal places in this case. It's binary places of digit places. Regardless, what's another one that's up here? Was please go away, you stupid thing. Let's just pick a random number. Let's say let's go with 86. Just to give another quick example. And then we'll move on to doing it the other way around. So 86. 86 minus 64 gives us 22. So we have 1 there. 22 is too big there. Oops. 22 is too big there, so that's 0. And then 16. Yep. 16 can go into 22. Minus 16 would give us 6. So there's 6 remaining. And then minus 4 gives us 2. So there we are. So 86 in binary, leading 0, 1, 0, 1, 0, 1, 1. So you see how this is, it's just a subtraction operation for each place for the binary switch being on or off. So hopefully that explains things, and that might have been a bit tedious there. This kind of explains it. And again, this was an answer key of, like, after I see this filled out, I go, oh, that's how they're doing it. And I look at here. So the decimal was 192. Oh, so you have one switch here, and then it can fit 1 in here, and then there's no more that's left. Because it would help if they just like erase this all out. And they were like, if like we're just focusing on 192, they go, oh, 192 minus 128. I apologize for writing like shit. That would give us 4. Oh, hey, look, 64 is what's left over. And then, of course, 64 minus 64 is 0, so the rest of it zeroes out. There you are. Let me briefly show you how they recommended you learn binary conversion. Here's a table of the switches being on. Memorize it. Where it did this for like each one. If there's a 1 over here, then it's this or that. They didn't show you like the methodology of drawing out a table and then calculating it. It's just memorize this table. Binary decimal memorization chart. Just memorize this. That's bullshit. That's bullshit. That's not how you teach. That's a fucking cop-out. That is shit educational methodology. You should feel fucking ashamed of yourself. You piece of fucking shit. I'm disgusted because this kind of shit wastes your time, and you're going to spend a lot of effort on it. You're going to be discouraged. There are going to be potential people who otherwise would have been engineers, that this is the hay that breaks the camel's back with, like, fuck this. I've run into so many of these tables where it says just fucking memorize it. I don't understand how to actually use it. I'm not being shown any demonstrations of how to apply this in a meaningful way. What the fuck was that shit with hexadecimal going on? How am I going to remember that when that's not even properly like fleshed out in any degree? Why the fuck was that even added in? It's disgusting. This is a blight. Poor educational methods are a blight upon society because it restricts people from attaining the level of knowledge that they would have been able to gain if you just presented it in a better way, you piece of crap. My God, I'm disgusted. I'm absolutely disgusted with poor educational methodology because it's not that fucking hard if you put effort into it. The students are going to put as much effort as they possibly can into learning something that they know is going to improve their life. I want to be a network engineer, so I'm going to try and learn this. They only have access to the information that prior mentors have put out there. So as a prior mentor, as the person who makes this information, this learning material, you better fucking do it well. You know better than to do things in a shitty way that's going to discourage students, and their lack of, it's not just like a lack of motivation on the students' part. Sometimes it absolutely is shitty educational material. Fuck. Okay. So let's go the other way around now. Not like this. No, I thought I had this filled out the other way around. We'll just do it. So we can just do this pretty simply. Let's make this larger so it's not so Confusing. Well, that was unfortunate. Come on, zoom in. It's not. It's gonna jump back, isn't it? Yeah, it's gonna jump back. Okay. So let's just move this up because this is gonna keep covering shit up. Actually, let's just do that because I'm not gonna fuck around with making things go way up here. I know that there's a command to hide this, but I don't fucking remember off the top of my head. So really, really simple. When you have to convert decimal, so I'm just looking at this 0, 1, 0, 0, and then it's a bunch of ones, 0, 1. Okay, so where are my, look for where I have the switches turned on. I have 4 of them here, and 0, 1. Okay, so let's add them together. 32 plus 16, 48. So I got 48, and that'll give me 52, plus 4 would be 52, and then plus 8 would be 60, and then plus 1, 61. Okay, so that goes to 61. So this is addition. So previously we were deciphering hex into binary by subtracting out things in the places, by subtracting things out and adding places to it. So this makes sense for how they're presenting it, where there's a fixed number of bits for each position. This was not discussed in the chapter, which kind of pisses me off, that, oh, there should be a fixed number of bits for the information explaining each, portion of the IP address. That should be made very clear. And I read each chapter twice, and then I take notes on it. So I read extremely thoroughly. And if something is not sticking in at that point, it's not my fucking fault. It's the quality of the material that is failing to convey something in a meaningful manner, which is why I'm doing this, to present this in a better way than the shitty fucking textbook that you can tell my frustration with it. Because, this is bad. This is bad. You are losing quality members of society by having shitty materials, which would convince people that they can't learn something. Okay, next one. We're just doing another. Let's change color just so that we distinguish it. So I got 3 ones in a row here, then a 0, then 2 more ones, then a 0. Okay, so that would be 6 over here, and we already did that as 48. So let's put those together and we get 54. So what's 64 plus 54 is 118. 118. There you go. So just have the stuff that just take each one in whatever position, and you see what that is in decimal, and you add them together like we did there. We're just going to do a couple more examples. Let's take this one. Actually, let's go with a green color. I love my lime green color. So real simple here, and then we don't even have to fill in this stuff. That's there. Okay, so we got 3. We're going to add 3 to this. 131. 128 plus 3 is 131. There you go. We got 131 there. Easy win. And just picking on the last one here. We got 1, 2, 3. Skip. 1. Skip. 1, 1. Well, we know that's 3 back here. Let's move that with the 8. So that would be 11. And then 32 plus 64 is 96. So that gives us what, 107? So 128 plus 107 equals 5. Carry the 1, gives us 3. That's 2. 35. 2. 35. Hopefully that was easy enough to follow along. I wasn't doing everything and like writing it top down. but hopefully that was easy enough to follow along. Let us do one more, and that will drive the point home. I'm going to pick one from the very bottom there. Actually, we'll do two because this one would be super easy. We have one over here and then one over here. So what's 128 plus 4? Would be 132. So that one, when there's just a couple of switches flipped, you only have to calculate the stuff that's active. So we only have 2 switches flipped. And like, okay, that's the position of the 4. That's the position of 128. 128 plus 4, 132. And I am trying to go a bit slow so that I don't misspeak with trying to cross my wires between mathematical and verbal. Okay, so let's take one final one that's pretty confusing. Let's go with another color. I do apologize if someone's like colorblind and watching this, because that would be a little difficult. 0, 1, 1, 0, 0, 1, 1. So that is 3 over here. And we have 48 over here, which this comes together for 51. And then 128 plus 51 is 179. 179. There we go. So this last one, just by matching up the switches there, gives us 179. If I made any miscalculations in doing this, then do let me know. I just wanted to give a demonstration for converting decimal to binary and binary to decimal in terms of like how would you manually do these IP addresses. This would be a good thing to add to your resume if you, for whatever programming language you use, to make a converter to take in binary and give out decimal, or to take in decimal and give out binary. Here's the math behind that if you were looking for a reference for how to do that. And also, I really needed to express my frustration at the poor quality of educational material that's involved in here. And actually, next time that I go to the library, I'm going to look for updated versions or alternate study guides to this, because I'm a little more than a third of the way through, about a third of the way through, and I'm really dissatisfied with the quality of this learning material for trying to teach the Network Plus, and I would not, if I were an editor, I would not let this be published as it stands. If I were like an editor that's looking for educational quality, I would have several serious revisions, and I hope that those revisions were made in more recent versions. Thank you very much for watching, and I hope I was able to teach something. See you in the next video.